Hey, let's greet each other properly here, guys. Good morning. This is Mr. Aynesworth here at Great Oak High School in financial algebra. Yes, financial algebra. And let's get started here. A couple things. If you guys are in my class, which most of you are watching this video here, all right, we do what we normally do, okay? We're going to do all our work in our spiral. So number one, all right, do all of your work in your spiral. So get that out and ready. Okay. Number two, all right, save and submit all your Desmos work. Okay. And so you notice I have Desmos over here on the right. Okay. And if you don't have that set up with the title and your name on it, well, pause the video and get that done. Okay. Save and submit all Desmos work. Okay. So let's get Desmos set up here. Here we go. You just click on the save button, all right, put a title in that makes sense, you know, something like this, section 2.9, finding the term of a single deposit, that's what it's called. Just read your workbook right there, and then put your name on it. I'm going to put my name in, but you put your name in, because you know what, when you submit it, it should have your name on it. Go ahead and, obviously, if you don't have an account yet, then form an account. Just type in Desmos.com, go to your graphing calculator here where you can save all your work, and then make sure you save it. I have all my work over the last few years saved here for all my classes. You should be doing the same. So go ahead and get that started and get that set up, and let's get started here. Now, solving these exponential equations takes logarithms, as you know, because I went through our last lesson here and prepped you on the basic properties of logs and how you solve an exponential function. So if you haven't done that yet, you probably want to watch my previous video on that, where I talked about the basics of logs and how to solve an exponential function using logarithms. Okay, so let's get started here. We're not going to do all of these. We're going to do a portion of these. All right, so this first group here, numbers 1 and 2, we're not going to handle these, okay? I can't do all of them, by the way, and nor will I do all of them, nor will I assign all of them, okay? Because there's just too many problems, and you don't need to do that many. So this right here, we're going to skip. Just make a little mention there. Okay, we're going to skip numbers 1 and 2, and we are going to start on number 3. Okay, again, this is section 2.9 in your student workbook in financial algebra, and we're going to start here on number 3. Okay, now once again, get out your spiral. Okay, I'm going to do my work off to the side, and then of course you're going to do yours in your spiral. So I'm going to pick a few of these here in this group here. We're going to start off with part C. We'll just pick this one just as an example here. All right, so this is 3C over here off to the right, and again, this is in your spiral, because there's no place to do all this stuff in here. To solve an exponential function requires logarithms, okay? And strap on your seatbelt, because here we go. Okay, so I'm going to take this equation, this exponential equation over here. I'm going to write it down off to the side so I can work with it. Here I got 9,800 equals 1,000 times 1.0025 raised to the 12t power. And notice that t is in the exponent. It says solve for t. Oh my goodness. Solve for t in each of the following compound interest equations. These are compound interest equations. These come from the main equation that you guys are well familiar with that I'm writing down. Okay, so all of these come from this equation. And so when we do our application problems, they're going to look like this. And so if you can solve these equations in number 3, you can solve anything. In terms of, in this section, that is, okay, leave your answer in terms of the logarithm. We'll talk about that and what that means. Okay, here we go. So I'm going to zoom in here. I'm going to take a look at our first equation, and again, go at your own pace here. If I go too fast, well, guess what, this is a video, so you can pause, play, rewind, right, and go at your own pace. All right, just don't sit there and copy, because that doesn't make any sense, much less is it any good for you. So go at your own pace. What I'm going to do is I'm going to isolate the exponential term, which is this 1.0025 to the 12t power. I'm going to isolate that by simply dividing by 1,000. Okay, you just use some basic algebra 1 skills here. All right, when you do this, you cancel out the leading zeros, and so I get 98 divided by 10. And so if you get that, let's see, 98 tenths is equal to 1.0025 raised to the 12t power. Now 98 tenths can be simplified a little further. If you divide both by 2, you get 49 fifths. Now it's really not necessary to simplify. However, I'm going to do it because that's what most people do. Okay, and so I'm just rewriting it here. So all I did was, simplify. Easy. All right, simplify. That's all I did. All right, you just simplify your fractions. So now what we want to do is we want to take the log of both sides. And there's 2 ways to do this, as I've talked about in class. Okay, so what I'm going to do is I'm going to solve this 2 different ways. Sorry. So, and then in reality here, you only have to pick one of the 2 ways to do it. Because it's an instructional video, I'm going to do it both ways. But in reality, all right, there is more than one way to do things here. So over here, we're going to do method 1. All right, using the common log base 10. So this is going to be common log. We're talking about base 10. I've talked about this in class. Method 2, over here on the right. Okay, I'm going to take the natural log base e. Okay, so base e. So two different ways to solve the same equation. So let's get started. So I'm going to rewrite the equation here. 49 fifths is equal to 1.00. Oops, too many zeros there. 0.0025 raised to the 12t power. And our goal is to solve for t. Okay, solve for t, the term. All right, which is the term, the length in years. Length in years. And that's the goal. Okay, now, once again, go at your own pace here. So pause and play throughout the video here. What I want to do, and again, there's more than one way to do this too. I can go from log form exponential form or straight to log form. That's how some of you guys were taught when you were in Algebra 2 or pre-calc. However, I have found that over the years, showing it the way I'm going to show it here is a little bit better for most students, especially students with basic calculators with only base 10 or base E on them, because most calculators, scientific ones like the TI-84, can only handle base 10 and base E on the front port of the calculator. So that's important to know, by the way. Okay, so base 10, what I'm going to do here is just take the common log of both sides. Okay, so here we go. I'm going to take the common log, which is base 10, up both sides. And then I'm going to be using the property of logs, called what I call the exponent property here. I don't want t to be in the exponent here. I got to solve for it. So I'm going to shift it to the front of the log. It's called the exponent property of logs. It allows me to do that. And I get log of 49 fifths is equal to 12t now. 12t times this log of 1.0025. Now, remember, my goal is to solve for t. Okay, the way I do that is simply divide by whatever's being multiplied by t. So I'm multiplying t by 12, so I'm going to divide both sides by 12. Okay, but I'm going to kill 2 birds with 1 stone here. I need to cancel out the log as well, so I'm going to also divide it by the log of 1.0025 on both sides. So notice the times symbol there. It's actually 12 log of 1.0025. Okay, now keep in mind that anything divided by itself is 1. That allows me to do this. Okay, so I get t is equal to some number of years. So at this point, we want to kick in Desmos, right? Right, in a minute. Okay, so before we get to Desmos here, we'll talk about that. Let's go back to the directions and read and understand what it means. Okay, so it says solve for t in each of the following compound interest equations. I did that. I solved for t. I got my expression here, which, let me write it down here. So it's log of 49 fifths divided by 12 times the log of 1.0025. That is the exact answer in logarithmic form. It says in terms of a log. So let's understand the directions here. It says in terms of a logarithm. That's it right there. So I solve for t in terms of a logarithm. Now, if you look at the publisher's answers, they don't have a decimal there. If you went to decimal form and you went and evaluated this in Desmos, okay, so let's just do it just for funsies right now. Okay, we're going to hit the function button right here, hit miscellaneous, type in log, okay, to take log of 49 divided by 5. All right, divide that by 12 times the log. All right, hit the function, go miscellaneous log. Just type it in directly as you see it. There we go. Okay, it gives you an answer of 76.174. All right, so I'll write that down too. Even though this is not the answer, okay? This is not log form, okay? So 76.174 is the approximated decimal, okay? But that's not what the question's asking. The question is asking you, all right, to solve for t, which I did. I solved for t in terms of a logarithm. Okay, so that's what this means right here, in terms of a logarithm. And the reason why they do that, okay, is to make sure that you guys understand the process. Okay, all of this, everything that I just explained right now, to get from the original equation all the way to t, which is equal to log of 49 fifths, all divided by 12 times the log of 1.0025. It takes some mathematics and it takes some skill. And that's what this thing tests. All right, anybody can plug something into Desmos. Okay, even a monkey can do it. I can't believe I just said that. Probably should strike that. Strike that from the video, okay, guys? I didn't say that. I didn't say that at all. Okay, so don't get mad at me. I was just being a little goofy here at 5:22 in the evening, when I should be relaxing. Okay, but I'm doing this for you guys. So, anyways, that's our result. Okay, so we don't want a decimal here. So no decimal, no Desmos. Okay, so no decimal. All right, no Desmos. Not when it says this. Okay, so if it says find the exact answer in terms of, let's say, the nearest tenth, all right, then you go to Desmos and then you get a decimal. But right now it just says write your answer in terms of a logarithm. And that is how it's done. Now, you do not have to do it using the common log, okay? You could use it with the natural log. All right, so now let's do it a different way. All right, so what I'm going to do, I'm going to rewrite the equation over here. And I'm going to do a similar thing, but I'm going to use the natural log, all right, instead of the common log. All right, so basically the same idea, but done with the natural log, which is base e. So the natural log is abbreviated ln. Okay, so you take the natural log of 49 fifths. You take the natural log, the natural log of 1.0025 raised to the 12t power. All right, now once again, just like on the left, notice this side-by-side comparison. You take the exponent, shift it to the front of the log. Okay, so here we go. You take the natural log of 49 fifths, and that's going to be equal to 12 times t times this log, excuse me, not common log, but natural log, of 1.0025. Now, just like on the left right here, we have to isolate t, and that calls for division, okay? We've got to divide both sides by 12 to cancel out the 12s, and you got to cancel out the logs, so you're going to divide by the natural log of 1.0025 on both sides. Just like on the left side. So I'm kind of repeating myself here, okay? And notice that I get a different expression dealing with the natural log compared to the first expression. All right, and that's okay. If you evaluated both on Desmos, you would get the same thing. In fact, you know what? I'm going to do that just for fun. Okay, so I'm going to evaluate these in Desmos. I'm going to show you that they're the same. Okay, so here we go. Let me see. I already did the first one here. Let me do the second one. So natural log, so you hit function, natural log, type in the fraction 49/5, and then divide it by 12 times the natural log. You can just type in ln, all right, at 1.0025, and notice you get the same answer, both 76.174. All right, so it doesn't matter which base you use. All right, you're going to get the same thing. But remember this, when it says in terms of a logarithm, all right, you want to not use decimals. Okay, no decimals. No. All right, it's in terms of the log. And guaranteed on a quiz, I will give you this kind of question because it tests to make sure that you understand the process, the mathematics behind all this. All right, that's why I'm going slow and detailed here, because you guys got to understand the mathematics. All right, you got to get smart, especially for those people who are going into engineering or higher mathematics in college. You better know your stuff. Okay, so pay attention to quality of learning versus anything else. All right, and that's why you should be going this at your own pace. Don't go fast, go slow. Now, what I want you guys to do tonight are a few other ones here. Okay, there's I want you to do part E, part B, and then part D. So do 3 more here. Check the publisher to make sure you're getting the right results. Okay? Okay. Now, number 4. Let's do one in number 4. Let me see here. You need to express interest. Find the value of t to the nearest tenth. Ooh. Oh, this is straight. This is just decimals. Okay, this is too easy. You guys are too smart. So you know what? We're gonna skip this. This is just a enter in decimals and write down the result. So skip that. Let's get to the more interesting stuff. Okay. Let's get to this right here. Number 5. Ooh. Okay, number 5. All right, let's do this. All right, because you guys don't want to do the easy stuff. You guys want to do the hard stuff. All right, like you're probably telling me right now, Aynesworth, let's get to the more challenging stuff right here. Enough of this easy stuff. Let's get on it, okay? In fact, you know what? Maybe next week let's do some calculus. Forget this pre-calc or financial algebra. Let's just get right into it. Okay, I'm just kidding. Okay, so let's do number 5. Enough of this talking here. And again, we're make sure you save your decimals work here. All right, number 5. Let's pick one here to do. So, no, actually, wait a minute. Let me read it. In each of the following compound interest equations, use logarithms expression. Ooh, use logarithms to write an expression for n. Ooh, you got to solve for n. Well, guess what? That's the same thing as what we just did up here. So number 5 is exactly the same as number 3. So we're going to skip that. All right, I'm not going to have you do things we've already done. So skip this here. Okay, let's do something a little bit more interesting. Okay, like number 6. Okay, 6 is interesting. Okay, let's do this one. Let's do arc over here to the side. All right, so here we go. Shannon wants to start saving for her retirement. Her goal is to save $350,000. Is to save. Ooh, that's like the future. Okay, that's a future amount. Future amount. Okay, so that's equal to B. Holy cow, future amount. Future value. If she deposits $250,000 into account, ooh, guess what? That's called the principal. All right, into account that pays 2.04 interest. Ooh, so R is equal to 0.0204. Okay, so there you go. We know the interest rate, and it's compounded monthly right there. So N is equal to 12 because it's monthly. So you know me. I always interpret and I annotate as I go, because otherwise you're not going to understand the problem. Okay, so we know the interest rate is 0.0204 as a decimal. We know it's compounded monthly, so N is 12. Approximately how long will it take? How long will it take? T equals question mark. How many years? I don't know. Find the T. For money to grow to the desired amount. We wanted to go from 250,000 to 350,000 in the future. So how long will that take? I don't know. Let's figure it out. Now notice this is non-periodic, okay? It didn't say anything about periodic accounts. And that's why the title of this lesson is finding the term of a single deposit account. So just notice this is non-periodic. Okay, this is a single deposit account. And because if it's a single deposit account, use B is equal to P times 1 plus R divided by N raised to the NT power. So you got to know your compound interest formula. And if you guys don't know this right now, at this point, since we've been working on it for so long, God, where have you guys been? All right, that is it. You got to have that memorized. Now, let's go ahead and let's go for number 6 here. We want the future to get, we want 350,000. P is the principal, what you put initially. So it says here, if she deposits 250,000. So you deposit 250,000, and then you put it in an account that pays 2.0% interest. That's 0.0204 is a decimal. N is 12 because we it's compounded monthly right here. Look at this, it's compounded monthly. So right there, there's your monthly interest rate. 0.02 divided by 0.0204 divided by 12 is called a monthly interest rate. And we're going to raise it to the n times t power. All right, now n is 12 because it's monthly. Look at that, monthly. And so it's raised to the 12t power, and you got to solve for t. All right? Solve for t, the term, the time, and number of years. Number of years. Here we go. Okay, so it's pretty easy. Just go ahead and divide by this constant here. Isolate your exponential term. All right, and then simplify a little bit. Anything divided by itself is 1, okay? And then over here on the left, cancel out the 3 leading zeros. 1, 2, 3, 4. Actually, 4 leading zeros. And you get 35/25. And they're both divisible by 5. So if you simplify, okay, divide both by 5, you get 7/5. Okay, so 7/5 is equal to 1 plus 0.0204 divided by 12 raised to the 12t power. Okay, now do not use a calc there on your fraction here, okay? So just leave it as a fraction, leave it all like this, okay? Because we're going to let Desmos do the work here in a minute. All right, so don't worry about that. It may look ugly, but don't worry about it. Now, we could take the common log of both sides, or we can take the natural log of both sides. If we use the common log, which is base 10, all right, this is how it goes, okay? So let's take the log of the left side, okay, which is 7/5. Take the log of the right side, which is 1 plus 0.0204 divided by 12 raised to the 12t power. And then you kick in your exponent property, okay? Now remember, every time you have an exponent of an argument here, it can shift it in front of the log. Okay, so let's put this in red again, because I've talked about in this prep before this lesson here, but shift the exponent to the front of the log. Shift the exponent to the front of the log. Okay, that's the key. All right, and when you do that, you get log of 7/5 on the left is equal to 12t now, 12t times the log of 1 plus 0.0204 divided by 12. And again, don't worry about how gnarly this looks, okay, because we're going to use Desmos here, and it's not going to be that bad. Okay, now remember, the goal is to solve for t. But remember the goal initially here. We're trying to solve for t. So there's our goal. All right, and to do that, I got to solve for t here. I got to divide by the 12 to cancel out the 12. But you might as well be efficient here and cancel out the log as well. So just divide by what you see on the right-hand side. You know, whatever is being multiplied by t, just divide both sides by it. Okay, it's that simple, believe it or not. And then when you do that, you get this expression here. Okay, so you get log of 7/5 divided by 12 log of 1 plus 0.0204 divided by 12, and that's equal to t. All right, the question is like, what in the world is this equal to? All right, so let's go to Desmos and let's figure this out. All right, so you type it in. All right, so type in, go hit function, select log, the common log. All right, 7 divided by 5. And then, oops, that's incorrect. Okay, so you got to get out of the denominator, then close out the parentheses, then hit the division button. So be careful there. And then multiply it by 12 log. If you're on a keyboard, you just type in log, but I'm using the digital keyboard here. 1 plus 0.0204 divided by 12, because we're doing this monthly. And notice what we're getting here, about 16.5 years. So 16.5 years is approximately t. Okay? It's that simple. Well, it may not be simple, but that's how you do it. Okay? And that's how all of these equations are done, believe it or not, in the entire section 9. All of them. They're all done with a similar technique. Every single one of them. That as well as section 10 as well. Okay, so let's go hit save right there. Let's go back to Desmos here. Let's take a look at it. So what have we done so far here? We've done number 6. Now number 7 is similar here. Okay, so I want you guys to do number 7. So this one's on your own. And again, you're going to be checking the publisher here. So on your own. On number 7, do number 7. Let me look at number 8 here. Okay, so number 8. Okay, we're going to skip number 8. Number 9. Number 9 you're going to do. So let's see here. 9. Ooh, we better do number 9. Okay, I'm going to do number 9 with you. Okay, so let's work on number 9. All right, last one, and then we'll do the rest of the next one. I see you guys. Okay, last one. All right, number 9. Jasper deposits 20 grand. All right, 20 grand in 20 grand is 20,000, 20K, into an account that compounds interest continuously. Ooh, compounds interest continuously. Right there, you have to switch functions. Okay, so you have to use the compound continuous function. So let's highlight that. This is an important problem here. Number 9, okay, test question. Because this one here is, instead of using the regular compound interest function that we used earlier, like right here on this one, that we used in number 6 and number 7 here, this is a compound continuous function. And when you compound continuously, guess what? You have to use the compound continuous function, which you see on the top of the screen. Okay, so Jasper deposits 20,000, so there's your principal, and at the rate of 3.4%, so 0.034 is a decimal, to the nearest tenth of a year. All right, so t equals some number of years, question mark, these are in years. How long will it take the money to grow to this? This is your future balance. Okay, it says grow, right? So to get from 20,000 to 30,500. So here we go. All right, so you always start off with what you are working with, and you're working with a compound continuous function. So you write it down first, and you substitute your numbers in. We want it to grow to 30,500, so that's B. We don't. We know that we deposit right here initially 20,000, so there's your principal. We multiply by e to the RT power. Now r is 0.043. Excuse me, I'm dyslexic. Sorry. 0.034, all right, and you got to multiply by t. So notice t is in the exponent again, and whenever you have to solve for a variable in the exponent, it calls for logarithms. And if you don't know how to use logarithms, well, guess what? You use Desmos. And I showed you guys how to do that. We use the graphing capabilities, and we form a system, and we solve it graphically. But since we know how to use logarithms, let's go for it. All right, so let's divide both sides by 20,000 to simplify things. You've seen me do this before. Anything divided by itself is 1. Simplify the leading zeros here on your fraction. Okay, that's called dividing by 100, so it cancels out the leading zeros. Just to simplify a little bit. All right, now we're going to be using Desmos here on this one here, so I can really, doesn't really matter. Oops, hang on. If we simplify your fraction or not. So what I'm going to just do, I'm just going to write it down. I got 305 divided by 200. There's my fraction right there. And what I'm going to do, is I'm going to just rewrite the equation just so I can see it better, and I get equals e to the 0.034 times t. Now this is base e. Now when you're base e, you could still use the common log, but most people would prefer to use the natural log. Okay, so using the natural log. Okay, and the reason why is because it's base e. All right, I'm gonna see what I get here. So natural log of 305 divided by 200. That's on the left. Natural log of e to the 0.034 t. So I notice I took the natural log of both sides. At this point, you're going to kick in your exponent rule and shift that to the front of the log. And I get the natural log of 305 divided by 200 is equal to this decimal, 0.034 t times the natural log of e. Now, at this point, you have to remember something about the natural log of e. And I talked about this in class. Okay, so we know, all right, the natural log of e is just 1. Okay, you can verify that with Desmos if you want. Okay, you just type it in. So natural log of e, just type in e. Notice it says 1. Okay, so it's always the case because e to the first power is e, and that's why that's the case. So that's 1. So this is 1 here. So really the only thing I need to do is divide by both sides by 0.035 or 0.034. That's all I need to do, and then I isolate t. Boom, right there. And that is where you kick in Desmos. So let's do that. Okay, so now just type it in. So functions, natural log, let's enter in our fraction, 305 divided by 200. Close it off before you hit the division button, 0.034, and you get about 12.4. Okay, 12.4 years. So t is 12.4 years, approximately. Okay, and that, my friends, is how you do number 9. Okay, hit the save button on your Desmos here. Make sure you save all your work because you're going to be doing a few other ones here. Let me see. We'll do number 10 together. This is together in class, in the next class period here. So we're going to do this with Mr. A here. That's me. Okay, in class, just wait for me when I get back. And I'll tell you what, we'll do number 11 as well together. We'll do this when I get back into class. Okay? All right, so you have a little homework to do. You have to do number 7. And then going back up to the first group right here, you have to do parts, it looks like. You have to do number 3, parts B, D, and E. Okay? Do that, check with the publisher here. And then we will continue when I get back into class and see you guys. Okay? All right. Well, I'm looking forward to seeing you guys soon. You guys take care. This is Mr. Aynesworth. All right. Bye-bye.